The number of galaxies in the observable universe also revealed to us the number of stars in the observable universe, which is most likely more than a sextillion. A sextillion is a number with 21 zeros. Considering that on average we can say that there is probably at least about a planet per star, we can then also say that there are more than a sextillion planets in the observable universe. That number is so large that we can be pretty certain that there are at least quite a few alien life forms out there currently, including complex ones and quite possibly civilizational alien life. Now, that is just the case for now, while the universe is still thriving. However, what about life or alien life in general of the really distant future? The universe existed for about 13 billion years, but there is essentially an infinity of time ahead of us. And throughout that future time, many moons and planets with vast alien ecosystems, including possibly alien civilizations, will come and go. Now, considering that the universe won't be lively forever, we can know that there will eventually be the last alien life forms that naturally form, and also the last ones that survive in the universe. Now, when and where will that be? You might think that that will happen when all stars eventually exhaust their fuel, leading them to become faint white dwarfs that cannot heat up planets any longer, and when eventually there is not enough leftover gas clouds and galaxies for new stars to form. Humans and many other organisms certainly are very dependent on light. However, it is not an absolute prerequisite for life to exist. There is an enormous deep-sea ecosystem on Earth at below 1,000 meters. That is the point below which sunlight practically doesn't reach at all. All the way down to 10 kilometers in Mariana Trench, there are even complex life forms such as sea cucumbers and amphipods. Now, yes, this entire deep-sea ecosystem below 1,000 meters is very likely quite dependent indirectly on the light-based ecosystem. But there are also many organisms that could adapt and easily survive if the light from the sun and thus light-based ecosystem disappeared. If the sun stopped shining entirely, the hydrothermal vents in the deep-sea ocean that heat up water would still keep the water liquid there, allowing for life to continue existing. Although likely a massive chunk of the ocean would be frozen then, and there would be a thick ice layer on the surface of the Earth. Now, in that apocalyptic scenario, even some humans could likely survive without sunlight, given enough preparation. So we have a part of the answer regarding where the last aliens in the universe could form. There are two possible places in terms of moons and planets. With planets, it's the ones that are very similar to Earth, in that they are planets that have lots of water and are very geologically active. That is to say, they have a molten core that is sustained through a number of possible processes. So, this type of planet, far into the future, with barely any sunlight, is going to most likely have a frozen surface. However, because of its geological activity, it will have hydrothermal vents, just like the Earth, which will make the water beneath the frozen surface liquid. With moons, it's going to be the same case. The moons that are going to have liquid water oceans are the ones such as Europa, the moon of Jupiter, which because of tidal forces due to Jupiter has sufficient heating to melt a good chunk of water below its icy crust, causing it to have an enormous water ocean. The same is true for Enceladus, the moon of Saturn. There are also many more moons that also very likely have water oceans beneath their icy shells. There are currently about 7 moons in the solar system that have strong hints about having subsurface water oceans. This indicates that most of the places in the universe which have conditions to favor life are actually places with subsurface oceans. This is very true for moons, but quite possibly also planets. That is quite possibly the case because those conditions are rather easy to get right. So then we can expect that the likelihood of the last alien life forms forming in one of these types of moons and planets is greater than on objects with surface oceans like the Earth. And that is especially true for the last forming aliens, since really far out into the future there will be less sunlight, thus less surface ecosystems like the ones on Earth. However, it's not 100%. Some of these last habitable planets in the universe could maybe have very specific conditions with just the right amount of geological activity in greenhouse gases, such that they have a surface temperature which allows for massive liquid oceans to exist on their surfaces even without significant sunlight or sunlight at all. However, obviously these planets or moons like that would be far less common, since first of all we don't know of such planets, and second of all, their conditions are way harder to get right, due to the sheer amount of specific things that would need to be in order. Now, when are these life forms going to form in those subsurface oceans? This is much harder to predict. There is an idea that if conditions are right, life forms soon after. That is an idea that came about from the realization that the Earth is about 4.5 billion years old, and there is evidence of life existing on Earth about 4 billion years ago, in the form of simple single-celled organisms. So this means that for the vast majority of the history of the Earth, there was life on it. So what I am going to argue for is that the right conditions for life, and thus life itself, could spontaneously form even after all stars and planets have stopped forming. So beyond what time point is that? So stars run out of energy. Every second our sun releases about 5 million tons, but that means that it still at this current rate needs about 37 million years to release the mass of the Earth. Now, when are stars going to stop forming? Although there is still plenty of time left in the universe, practically infinite, the star formation rate has already reached its peak about 10 billion years ago. Currently, 10 billion years later, the star formation rate is 3% relative to that peak. And as we go forward into the future, it is going to further slow down. However, that is an extremely long process, with a low estimate for when star formation is going to end, saying that it is about 1 trillion years from now, meaning that until the current age of the universe is surpassed about 75 times is when the low estimate is saying that the star formation is going to stop. Now the high estimate is placing that number at 100 trillion, meaning that when the current age of the universe is surpassed about 7,500 times is when the star formation is going to stop. That is a lot of variation between the high and the low estimate, but nonetheless it gives us a very approximate idea of beyond what time point are the last aliens going to form. So even after all of the stars in the universe have exhausted their fuel and can't sustain fusion anymore and are turned into faint white dwarfs, there still will be gas giant planets that have moons with the size and composition of Europa. However, their moon might have at first been really far out in the orbit of the gas giant planet, but slowly, because of orbital decay, over trillions of years, as the stars died out, the orbit shifted closer to the gas giant. In such a case, given the similar composition to that of Europa, which is not rare at all, as established, that would mean that the moon would gain the right conditions for life, as because it would be closer to the gas giant, there will be a greater amount of tidal heating occurring, and thus that would create a subsurface ocean, allowing for life to form. But why exactly is there so much focus on water in terms of life conditions for these last aliens? To some, it might seem like water is not a requirement for life, and it really might not be 100%. However, there are good reasons for why we can expect that these last aliens are going to be water-based and carbon-based, just like us and everything else that is alive on Earth. So first of all, we have proof that water and carbon-based organisms are possible. Proof of that being everything that is alive on Earth. Second of all, water is extremely common in the universe. It is made out of hydrogen, which is the most common element in the universe, and oxygen, which is the third most common element in the universe. And it shows. Pretty much most of the planets beyond Mars in the solar system have moons that have massive percentages of water as their composition. Now, another thing that gives humans and everything else alive on Earth structure is carbon, the fourth most common element in the universe. The reason that life on Earth is carbon-based is because it is exceptionally good at forming very complex molecular structures, which are the basis for life, such as DNA, proteins, vitamins, carbohydrates, fats, and others. The largest known protein and molecule in the human body is called titin, which contains 539,000 atoms. Carbon allowed for that to happen. And the reason carbon is exceptionally good at making these structures is because it has the ability to form 4 stable bonds. Now, there are other molecules which could be seen as potential candidates for making life forms, such as silicon, which also has the ability to form 4 bonds. But it is a whole lot worse at making 4 stable bonds. It is way worse in forming the necessary complex molecules for life. Other elements have even worse prospects for being the basis for life, as they are usually simultaneously worse at making complex molecules and are also way more rare than carbon. On top of that, carbon molecules pair up well with water, which works as a solvent. It dissolves the essential material for life to work. On top of that, it retains energy exceptionally well, allowing for efficient and necessary chemical reactions to take place within organisms. And water is one of the most common molecules in the universe. Now, taking into account that no other elements and molecules are as common and as good at making complex molecules as carbon, and that carbon pairs up well with one of the most common molecules in the universe, which is water, then that gives us the conclusion that, well, most alien life forms are going to be carbon-based, with water used as a solvent. Among some of those very rare last celestial objects in the universe that hold life, a few of them are likely going to have superbly stable conditions, such that they can go on sustaining oceans and thus life for billions and possibly many trillions of years to come. And in those cases, that is more than enough time for not only life to evolve into something extremely complex like a fish, but it is also enough time to possibly give rise to civilizational aliens. That's right, civilizational aliens in the subsurface oceans when stars themselves are starting to die out. It's possible that these civilizational aliens and many other organisms within that ecosystem develop similar traits to the ones that some organisms on Earth have. That could be the case because of something called convergent evolution, which is where you get the exact same trait from 2 distinct, independently evolving species. One such example is sonar, the ability to gather visual information based on sound waves. That is to say, based on echo. Both bats and dolphins have that ability, even though they are extremely distantly related, sharing the common ancestor about 60 million years ago. With that example and many others, we understand that similar situations can give a rise to similar adaptations, meaning that those organisms on those celestial objects, trillions of years from now, are possibly going to develop very similar adaptations to some organisms that are present on Earth. Now, in terms of those civilizational aliens, they probably would need to orient themselves in a pitch-black ocean. And one way to successfully do that is through sonar. Light wouldn't be needed for them to create visual information then. However, they could also be making use of a light that they themselves produce in order to orient themselves. However, that would be far more costly and less useful for gathering visual information in a vast, dark ocean. Sonar would give them a much better ability to gather input even kilometers from where they are, making sonar the likely primary visual system adaptation for such species. It is the most reliable and effective source of information underwater where there is essentially no light. Another possible and way less certain adaptation that they could have is something akin to hands that would allow them to manipulate materials around them to a very sophisticated degree. This doesn't mean that it would necessarily look like hands, but it should have the same function as hands. Possibly it could resemble something like the arms of octopuses. Although this does seem reasonable, as hand function adaptation allowed humans to build extremely complex things, it doesn't necessarily mean that that is the only way to build tools and structures. A complex enough communication and efficient coordination between these civilizational aliens could allow them to build complex things even without a very useful adaptation like this. What those aliens are going to be like in other aspects body-wise is extremely hard to speculate on, and even harder in terms of what their civilizational structure would be like, and what behavior in general would they display. If these aliens get sufficiently advanced, they might be able to pierce through the ice layer above them and reach the surface of the celestial object that they are on. They would, of course, probably need to have special suits to survive the surface, which they are not adapted to. However, because there is a good chance that they won't have any organs to sense electromagnetic waves, that is light, then they could maybe come to the conclusion that there is nothing beyond their moon. However, they might develop or already have tools to register the electromagnetic spectrum. And with that, they could register that there is a gas giant planet that they are orbiting, that is, if they are on a moon. And further, they might be able to detect white dwarf stars if they are orbiting one, the remnants of stars that once had fusion. They could do that in a similar fashion to the way that humans can register wavelengths beyond the visible light using instruments. Those aliens too might be able to use their own instruments to register them as well, including visible light, if there is any at that point. The amount of leftover stars that are shining in galaxies is going to be way less. And on top of that, galaxies by that point will be immensely separated. Now, this planet that these aliens are on might not even be a part of any galaxy by that point, as it could have been ejected over the enormous time frame. Considering that distant future, then even those very advanced aliens with very advanced instruments might not be able to piece together the history of the universe, since they arose in a time when the universe is extremely spread out and is entering near total darkness, where galaxies are separated by such immense distances that they basically leave no trace left for these aliens to pick up on. Now, that was all about some of the last aliens that could potentially form in the universe naturally. However, when it comes to the last aliens in the universe that survive, that is quite a different story. That is because there could easily be an advanced civilization that formed some many trillions of years before all of these mentioned last forming aliens, back when the universe was still very much thriving, and then that alien civilization found a way to survive throughout the entire time of when the stars are slowly dying out. Only those civilizations that truly master the knowledge of how the laws of the universe work will be able to use that knowledge to survive in an ever-expanding and less energy-dense universe. Just maybe that civilization will include the descendants of humans. I'm not saying humans, because by that point, trillions of years from now, those quote-unquote humans would likely look and behave significantly differently from what is currently present. If not biological descendants of humans, it might be the generally intelligent machines that we create that get to survive this far out. Whether it is the last aliens, alien machines, or humans and human machines that get to survive this long in the universe, another question arises. For how much longer will they be able to do so? What are the last surviving alive or semi-alive things in the universe going to do? Even all of the extremely stable moons and planets with subsurface oceans will eventually stop being able to support liquid water. Even if that is many hundreds of trillions of years into the future, it will eventually likely happen. Now, when that is the case, when there are no naturally habitable environments, for how much beyond will advanced life be able to survive? Some hypotheses tell us that even atoms themselves will eventually start to fall apart, because there are things to suggest that proton can decay over enormous periods of time. Meaning that, since proton is a part of the nucleus, if it decays, it would ruin the structure of atoms. If that is true, these future aliens would need to know how to overcome that problem. Whether or not there is an actual limit to the ability to survive indefinitely in the universe is far from certain. It's possible that, with sufficient knowledge, any obstacle that the universe can throw at life could be resolved. However, maybe not. Maybe there simply is a limit beyond which the problems of the universe cannot be surpassed anymore, leading to life in the universe completely disappearing.